Well, I'll go ahead and get started here, and maybe others will trickle in. Thanks for joining. Thank you for the sponsors, Sequent, Pragmatic Institute, and ProdPad, uh, making it possible for us to do this streaming version of Product Camp Dallas. Uh, this is the first time I've been to something like this, and it's very cool that we have the opportunity to share and learn from others in our industry in this space. My name is Stephen Kilbourn. I'm a quality engineer at Dialexa. So uh, my role at Dialexa is a little bit unique compared to some other companies. So some engagements I'll work as a Scrum Master, some I'll be a product owner, and some I'll be a little bit more focused on quality processes. So it might be giving how we'll be doing our workflows. Sometimes it may actually be uh, in the in the weeds, writing automated tests. And so I'm trying to bring some of that knowledge from writing tests today to this session topic, which is automation does not replace collaboration. So I love writing automated tests. I think it's a very valuable thing, but it's something that I think a lot of product owners, when they hear that they're being written, don't really understand what's going on. They don't realize there's a lot of nuance to what a automated test can catch. So my goal in this session really is to give some of that insight into what's happening, and to make it so you can use it as a useful tool and not just something that really you're hoping is going to catch every single error, and that it's not really possible. But instead, use it as something to enhance the way your team works together, and realize where there are weaknesses, you can collaborate and work together as a team to make up for those weaknesses in your test. So the structure for this session, I'm gonna, from a high level, talk about the different test types. Um, if you are not comfortable coding, don't worry. I'm not going to get into actual code and look at how to write tests. I want you to understand really what the various tools available to developers are and how they interact. But once we get that, we're going to look at a fictional product and a user story and see how, once you break that down into a user story, how a developer can actually write some tests. Uh, and then once we have this product and user story that's tested well, we can look at areas where collaboration can improve beyond what the automated testing itself can do. So, as I said, there are many types of tests. Being a quality engineer going into projects, a lot of times people just assume they may know the word selenium, they may so they may default to that. But there's actually a lot of types of tests that each have their trade-offs. Some are faster, some are slower, some are more um, give you a lot more confidence than others, but they're all useful for to be used within our product. But before we really dive into the different types of tests, I'd like to jump it to stop and think about why are we even writing these tests? And I think in writing tests, there are three goals. One of those is to have confidence in what we deliver to the end user. And we're all out here trying to deliver a really good product. And we want to be as confident as possible when we give them something, it's what we intended to give them. The next goal in our test is to provide fast, accurate, reliable, and predictable feedback. That feedback is going to be mainly to the developers and the product owner that, hey, we made this change. I can be confident that if I put this in front of the client, it works like we intended. And I want the feedback from my test to be very reliable and predictable. That meaning I don't want my test to fail if there's not a genuine issue with what I just changed. If I know that I'm going to have out of 100 tests, five of them fail every time, I don't care about those five tests. I'm just going to start ignoring them. So I want to make tests that are very reliable for me. And then the third reason I think is tied into this, and that's to give confidence. That's to make maintenance easier. Um, what I mean about that is if I make a change, I want to make sure that if I do break something, I can catch that very quickly and go and change that on those other areas of the application that are also broken. And if I break something and a test fails, I want to know very quickly what actually broke so I know how to fix that. So, with those goals of tests in mind, I'm going to look at this image of the testing pyramid. So, this is something that's been around, I think, about 15 years now. So, it's not new. You may have seen it. But it kind of breaks down the types of tests into some buckets and puts it visually. So, stuff at the very top of this pyramid give us a lot of confidence. It's like the peak. It's the um, gives us as much confidence as possible, but they're also very costly. It's going to be very time consuming to maintain these tests, and it's also going to be time consuming to run the test. The stuff at the bottom are normally very easy to write comparably, um, and they are also very quick to run. We're talking fractions of a second to run as opposed to seconds or maybe minutes up at the top of the pyramid. But kind of diving into the actual definitions of each of these terms, uh, starting at the bottom is static tests. Static tests I put here as typos. It is something that can be done by a developer's terminal, their code editor, almost instantly. You're not actually running the test, but it's looking, it may be actual typos, or it may be that something that's actually valid code, valid syntax, but it's not a best practice. And some tools are even advanced enough that as soon as a developer hits save, it'll fix those things for them. Going up on the pyramids where we're getting to more the actual genuine automated test, and that is called unit testing. So unit testing tests a piece of code on its own. The developer is going to write a function that it may be something very simple that's returns true if it's daylight outside, and they're going to mimic that input that says it's daylight outside and make sure the function really returns true. Going up, the next step is the integration test. Integration test is going to let you tie several pieces of code together. It may take several units from that same piece of your software architecture and make sure they work together like you expect. It may actually take several layers. It may work with two services that normally are running independently and make sure they tie together. And then the final one, the like peak of our pyramid, is the end-to-end test. These are tying all the layers together. Looking at this at another way is I'm going to look at kind of a typical architecture, a three-tier architecture. So you have a front end, you have a back end, and you have a database. The testing pyramid, our unit tests are going to actually be living on each of these layers. You're probably going to have in a big project hundreds, if not thousands, of separate unit tests, trying to test as much as possible of the business logic that's going on in your code. You're then going to have some integration tests. Some of those integration tests may be tying several units together, or they may be tying part of the back end and front end together to make sure they talk together correctly. And then you have the end-to-end test, the whole shebang, trying to act and exercise this system as closely as possible to what the end user is going to see. So we're going to try, in this case, from the front end, going to the back end, all the way to the database, and then making sure that responses come from the database. So with this concept, kind of starting to understand these from a high level, let's start looking at an actual product and how these different types of tests actually are going to cover a user story. So I love to work out. So my default user story and product here is going to be around an app that lets me log my workouts. And so I'm going to have a feature, and my user story for that feature is going to be, uh, as a user, I want to create an account to save my workout data. My design team's given me this nice wireframe. Um, so it's a form. We've probably all seen something pretty similar. Put in your name, email, and password, and then you sign up. So as the product owner, I'm going to need to have some understanding of the architecture and break down either into smaller user stories or tasks within that user story. Have the front end, make sure they render the inputs, make sure they validate those inputs, and then make sure the front end correctly submits the form. From the back end, I'm going to have them create the correct API endpoints with the data fields I need, and make sure the APIs, that backend is correctly writing to the database. So through the magic of my development team, they're going to take those requirements in that wireframe and build out the little application. So you can see it looks pretty much like the wireframe. And if they are writing their unit tests, each layer is going to have cover a lot of those same acceptance criteria that we did. So my front-end unit test, I can check that the inputs are all being rendered correctly. I can validate the email format is correctly, validate the passwords match, validate the passwords have the correct formatting so that there's enough, if there's a minimum number of digits, or I have to have a non-alphanumeric character, things like that, make sure that all happens, and give an error if that doesn't happen. And then make sure that the front end's form is actually submitting and calling the back end. And then make sure that error messages show up correctly in any case that there is an error. My backend developer is going to do similar. They're going to write a lot of unit tests. They're going to make sure that the APIs have the correct data fields with the right formats. They're going to make sure that that API is going to pass the correct response back to the front end. And they're going to make sure they can actually write to the database when those endpoints are called. So for an end-to-end test, it's a lot more intuitive from a product owner's perspective. We're actually writing tests that act and behave very similarly to the end user. So the end-to-end test flow is actually going to do a lot of what your user story would say you need to be doing. My user needs to visit the home page. They need to navigate to the registration page. And then now that they're on that new registration page, they need to fill out the form. And then they click on the sign up button, and I need to verify that the new user was created. So since the end-to-end test is not code heavy, I will demonstrate here. And you can see that test actually running. And as things here on the left of that pane go green, you see each step is successfully completing. And in just under 2 seconds, I was able to make sure a user successfully called my backend, talked to the database, and created a new user. So with that in mind, I've actually built out an application that has a lot of tests, and I have a lot of confidence in what I'm delivering, but I still think there are ways that we can improve without strictly relying on my end-to-end test and my developers writing unit tests. So to understand what I mean, I want to circle back to why do we actually write these tests? And I think the reason we write tests is to have confidence in what we deliver, and then also provide that fast feedback and help us make maintenance easier. So we're not just writing tests with the expectation to catch everything. It's never going to be possible, but we want to have it as much confidence as possible when we're deploying things. So instead of relying completely on end-to-end tests and unit tests, expecting them to catch every bug, I think it's important to think about what we can, how we can talk to each other and improve things. And one of the first things is having better requirements. As a product owner, you can spend a lot of time trying to create as detailed uh, user stories and requirements, acceptance or criteria on those user stories. But you're probably never going to hit that 100% mark. Uh, in this user story that I wrote, I didn't give any expectation. Like when a user hits a sign up button, what happens? Does the user automatically get logged in? Do they get thrown back to the home page? The way I built it out is it goes through this login screen. So now they have to retype the email and password they just created. Uh, a lot of times you'll see developers not have that. And so they have to build something, not have that requirement. So they have to make a judgment call. If we're having these constant conversations with your three amigos, your quality engineer, your developer, and your product owner, you can get to those points where you're just like, oh yeah, we did not think of that. What do we actually want for this product? And that uh, makes sure that we're all aligned on those expectations. It can be very frustrating for a developer to think they got everything correct. They move on to the next task, and the next thing they know, oh, you built that out wrong. But by having these constant conversations, we can minimize that feedback and that churn cycle of having to pick up back pick back up the same user story and keep fixing things that they thought were correct. The next thing is automated tests aren't great at catching visual changes. If you noticed earlier in the slides, all those inputs were shifted to the right instead of being centered. And that was actually a small typo when I was building it out that I decided to leave in for this. Um, and when you're down, heads down writing code, sometimes things like that don't stick out to you. But it can be very easy to have these conversations. So before you say, hey, I'm done, let's get a second pair of eyes or a third pair of eyes with your uh, teammates to look over things. There are automated tests and AI powered things that will give you feedback if there is a visual bug, but normally those require a baseline. And so if I've never even had that second or third pair of eyes giving me a baseline, I can keep validating, yeah, this is good, but really I should have fixed it and had it centered. So I really think it's important to bring those multiple perspectives of those extra pair of eyes and just look for weak spots in your testing. So those visuals, one that I gave here, it can also be like sometimes another browser that the developer is not always in IE 11, so they may slip through. But when you're having those conversations of, hey, um, a lot of users are using IE 11. Let's sit down and look at common issues that we're seeing in IE 11. And we can, before we even start the story, we can make that a priority. The third thing is test strategy. So it's something I see a lot of um, quality engineers or SDETs go in and write automated tests, is they have every single acceptance criteria written as an end-to-end test. And you can do that, but if you recall that test pyramid, end-to-end tests should be the fewest number of tests for the different types of tests because they can take a lot longer to run and because they can be a little bit flaky if you're not careful. That because you're actually doing something from the front end, making a network call across the internet to the back end and to the database, and then waiting for a response. Sometimes just weird things happen and it takes longer than the person writing the test expected, and you get a false error. So you might see a test like this that checking my validation, and yes, it runs, it works. It takes close to 3 seconds or close to 4 seconds to run uh, and check those two requirements. A unit test can actually test this because if you recall from um, the way our application was built out, the front end is the one doing the validation. There's no need to call a backend. There's no need to talk to the database. So hopefully the developer writing the code for the front end has already written a unit test to validate this. Those unit tests run in fractions of a section, in fractions of a second, and they are super reliable. And I don't even have to wait for a build of this application to get out and get deployed. The developer can test this before they even merge in changes of their code. So having those connected team members for the quality engineers, not just over the fence or in some other building writing some automated tests, but instead they're having constant conversations and they're involved in the development process. They're able to know that, hey, this requirement does not need to be tested at the end-to-end level, but it does need to happen. So I need to have that conversation with the developer on the front that's writing stuff on the front end to make sure that they actually write the unit test like they needed to. If not, we need to make sure that does happen. But I don't need to repeat everything that they've already done and do it with a poorly designed test suite. And I think the next thing that can be improved by collaboration is actually our velocity. A lot of these things kind of hint at this. And when we are working in silos, developers tend to build something, they think they've gotten everything correct. They throw it over the fence to a quality team. The quality team ends up testing it and they may throw something back. Now the developer needs to drop what they had moved on to figure out what was wrong with what they did the first time, fix that. Then the quality team picks it back up. They might think it's good this time and hand it over to a product owner. Product owner is like, wait, this isn't what I anticipated. So then we got to repeat that cycle. And sometimes you get caught up in those endless feedback loops. I think it's really important to just share the accountability, have these conversations with your three amigos, your product owner, your quality engineer, your developer. Sometimes you even need to bring in the design team that if they're involved, and make sure you have those conversations of what was the expectation, what does the end user really want, and because we are narrowing down the requirements, we're getting all those extra sets of eyes, and that we're able to get everything planned out the first time, built right the first time. We're not forcing a developer to do a lot of context switching, and now they're able to really get things right, build out what we want for the end user, even if we had not thought about it when we were writing the user story, and get that out the door with fewer bugs later on down the road. So really just trying to recap those four main things is test cannot make up for misaligned expectations. If a developer thinks that A should happen, they're going to write a test that A should happen. And if that's not what the product owner or the designer had intended, then it's not going to work out. It's also good to keep having these conversations because tests cannot catch everything. They are getting more and more amazing, and that will continue to happen to get better and better test suites. But there's always going to be things that a group of people that are invested in the quality of the end product are going to do better than um, some software that's scanning your code. And then I think when you have very connected, very involved team members all working together, they're going to understand better how the application as a whole is built. And they're going to be able to look for ways to make a better product, make it better, easier to support product, because you're testing things correctly. You're able to give feedback very quickly, so that I know, as a developer on the back end, I'm not, or on the front end, I know right away when a test breaks, what line of code do I need to go to fix it. It's not a 2-day process of we take a build, we hand it off to a team, and they run things. And instead, we're constantly talking to each other and saying, hey, this is breaking, this is what broke. And because we have that constant conversation and we're all accountable, it's not waiting for QA to go find all the bugs. We're able to have very quick release cycles and get more and more releases out the door every day and every week. So kind of a small crowd, so rush through that. But if anyone that is here has questions, I can take some. Okay. Well, thank you for those that were able to join, and hopefully you're able to jump into some other. Yeah, thank you, Ian. Yeah, uh, and thank you for everyone that's helping put this on. It's a lot of options out there, so going to go look for some of the recordings